Today we will discuss about graph theory. Suppose this is a network. This network contains several number of energy source and various resistors. If I want to analyze this network, we have to apply several number of network laws, that means KCL and KVL, and several number of network theorem. But we do not know what will be the required number of KCL and KVL equation is required to analyze this network. But it will be easy for me to analyze this network by converting it into its equivalent graph. So how to convert this network into its equivalent graph, we will discuss here. Now this network has 4 nodes. This is node number 1, this is node number 2, this is node number 3, and another node is 4. So this network has 4 nodes. Now any electrical network can be converted into its equivalent graph by replacing voltage source with short circuited and current source with open circuited. So this is node number 1, suppose 1, this is node number 2, and this is node number 3, and suppose this is node number 4. And this is one branch. So suppose this branch is A. So 1, 2, 3. So this is suppose branch number A. And this is another branch. Suppose this branch is B. So this is branch B. And this is branch suppose C. So this branch is C. And this voltage source is short circuited, that means this branch suppose D. So this is branch D, and this branch is E, suppose. So this branch is E, and this branch is F. So this branch is F. But this portion is open circuited because this is a current source. That's why this branch will omitted because this is open circuited. Okay, so this is the equivalent graph of this network. So what is the basic things to convert a network into its equivalent graph is the voltage source and passive element. Passive element must be short circuited and current source must be open circuited. So this is the equivalent graph of this network. Now to study about graph theory, you have to know some relative terms related to graph theory. Number one is tree. Number two is co-tree. Number three is twig, and number four is link. Okay, so this is the four parameter we should know to study graph theory. First of all, we will discuss about tree. What is this tree? Suppose this graph has four nodes. So number of nodes is equals to 4, and this network has 6 branch, 1 2 3 4 5 6. So this is node n, and number of branch is b equals to 6. We have to connect the 4 nodes. So this graph can be written as, this is number 1 node, this is number 2 nodes, number 3 nodes, number 4 nodes. So you can connect this 4 node using this, in this way. You can connect these 3 nodes, 4 nodes in this way. In this way, you can connect this 4 node in this way. In this way, you can connect this 4 node 1 2 3 4. You can connect this 4 node in this way. All the cases we have connect 4 nodes with some branch, but this 3 is different from this. Okay, so this 3 is different from this. What is the difference between this picture? Here the 4 nodes are connected using minimum number of branch without making loop. So in this case, loop is not making, is not made. Here is loop, there is no loop. In this case, there is no loop. In this case, there is a loop. So this is not a tree, but this is a tree, this is also a tree, this is also a tree. So what is the tree? Tree is the collection of minimum branch, connecting all the nodes of the graph. So what is this tree? Tree is the collection of minimum branch connecting all the nodes of the graph is called tree. So what is the properties of the tree? The properties of the tree is, Number 1, there should not be a loop. There should not be a loop in tree. Okay. Number 2 is one graph may contain several number of tree. So one graph may have several number of tree. So single graph may contain several number of tree. See, what will be the number of tree of this graph, any graph? So number of tree is equals to n to the power n minus 2, where n is the number of nodes of the graph. If you want to calculate the total number of tree of this graph, here the number of node is 4, so 4 into 4 minus 2, so it will be 4 to 16. So in this case, this graph contain 16 number of tree, but this formula does not hold for all the network or all the graph. Okay, there are some limitation of this formula we will discuss later. Number 4, all the tree must contain all the nodes. So tree must contain all the nodes. So tree must contain all the nodes of the graph. Okay, so we have discussed how to convert a network into its equivalent graph. Number 2, we have discussed that what is the tree? Tree is the minimum number of branch connecting all the nodes of the graph without making loop. So what is the properties of this tree? Number 1 is there should not be any loop in the tree. Number 2 is tree must contain all the nodes. Number 3, single graph may contain several number of tree. Number 4 is number of tree is equals to n to the power n minus 2, but this formula does not hold for all the trees. There are some limitation we will discuss later, but now we will discuss what is co-tree. What is co-tree? We have already draw that one tree. Suppose this is 1 node, this is 2 node, this is 3 node, this is 4 node. One node, one tree. Suppose this is a one tree, and another tree is, suppose this is 1, this is 1, this is 2, this is 3, this is 4. Suppose this is another tree. So this is a tree, this is a tree of this graph. We have to know what is the co-tree. This branch is D, this branch is D, this branch is E, and this branch is F. And here this branch is B, this branch is C, this branch is E. So this is the one tree of this graph, and this is another tree of this graph. Now, what is the removal of the branch to make this tree? We have already removed this branch, and this branch. That means B, C, and A. So we have removed branch B, branch C, and branch A. Okay, so to make this tree, we have removed B, C, A branch of this tree, and here we have removed this branch. So this is one. So this branch, that means D branch is removed, and this branch, F branch, is removed. This is 4, this is 3, and this branch is removed. That means A. So if I make a loop with the removal of the branch when you make a tree. So this is the co-tree of this tree, co-tree of this tree, and this is the co-tree of this tree. So what is the definition of co-tree? The definition of the co-tree is, so co-tree is a subgraph which is formed with the branch that are removed while forming tree. So this is the co-tree. So co-tree, there is several number of co-tree of this graph. So number of co-tree and number of tree must be equal. Number of co-tree and number of tree must be equal. So number 3 is twig. What is the twig and link? Twig and link. The branch of co-tree is link. So there is a branch B, C, and A. So branch of co-tree is called link. So this is link. What is this? Branch of co-tree is called link, and branch of tree is called twig. So here is twig is D, E, F, and in this case link is B, C, and A. This is case number 1, and case number 2, this is case number 2. In this case the twig is B, C, and E, and here is A, D, F. So the branch of tree is called twig and the branch of co-tree is called link. So this is the 4 relative terms to this graph theorem. Now we have to relate the number of nodes, number of branch and number of link. So suppose the n is the node, b is the branch and l is the link. The relation between these three quantities is branch must be equals to n minus 1 plus L. So this is the formula, this is the relation between these three quantities. Number 1 branch, number 2 is node and number 3 is link. Now what will be the KCL equation? So number of KCL equation must be equals to n minus 1. N minus 1, that means the number of twig. What is the twig? The branch of tree is called twig. So in this case we have 4 nodes, 4 minus 1, that means 3, and we have already see that the branch of the twig is 3. This is 1 2 3. In this case also 1 2 3. So number of KCL equation of this network is 3. It also called rank of the graph. So using this formula you can say that what will be the minimum number of KCL equation to analyze this network. You can calculate easily. This is the number 3. Number 2 is number of KVL equation. Number of KVL equation must be equals to number of link. What is the link? Link is the branch, number of branch of co-tree. Okay, so this is link. From this formula you can write that L must be equals to B minus n minus 1. So it will be B minus n plus 1. So using this formula you can also calculate what will be the minimum number of KVL equation to analyze this network. By using this formula you can calculate. Okay, so this is the main theoretical part of this graph theory. Now we will solve some numerical problem related to this theory. Suppose this is a this is node number 1, this is 2, this is 3, this is 4. So this is node 4. This is branch A, B, C D, E, F. So the dotted line is co-tree. See, dotted line is co-tree. Co-tree. You have to find out what is the fundamental loop. So calculate fundamental loop, number of loop. So you have to, in this graph, you have to calculate what will be the fundamental number of loop. What will be the fundamental loop? So loop will create number of KVL equation. So in this case, to calculate the loop, we should calculate the number of KVL equation. In earlier, we have already discussed that what is the number of KVL equation. KVL equation must be equals to the number of link. Okay, so if I able to calculate what will be the number of link of this graph, then we will calculate the number of fundamental loop. So here number of node is 4, number of branch is 1, 2, 3, 4, 5, 6. So number of branch is 6. Now this is the formula. Branch is equals to n minus 1 plus link. So L equals to B minus n plus 1. So B is 6. So 6 minus 4 plus 1. So it will be 3. It will be 3. So this is the number of link. So what will be the loop? You have to denote which one is loop. So here this is one loop and this is one loop and this is also one loop. So suppose this is the direction of this current flow. This is the direction of current flow. So this is another loop. So there are number of loops is 3. So which is the loop? This is A, this is D. So you have to start with D. So D, F and A. This is number 1 loop and this is D, B, E is another loop and F, E and C, this is another loop. So this 3 loop is here. So number of KVL equation of this graph is 3. Now you have to find out another problem number 2. Problem number 2. Suppose this is a node 1, this is 2, this is node number 3 and this is 4, this is 5 and this node is connected in this way. This is the branch. Okay, this is the branch. Okay, So suppose this is A, B, C, D, E, F, G, H. So from this graph you have to find out, number 1 is twig, number of twig, number of link. 3 is fundamental loop, fundamental loop, fundamental loop. Okay, so from this graph you have to find out these 3 terms. So how to calculate this? So here is the number of node is 5 and number of branch is 1, 2, 3, 4, 5, 6, 7, 8. So here is number of branch is 8. By using this formula B equals to n minus 1 plus L, you can easily calculate L. So L equals to B minus n plus 1. So it will be this is branch is 8 minus 5 plus 1. So it will be 4. So number of link is 4. So number of twig and number of link must be equal. So because each core tree has its tree, so number of tree and core tree must be equal. So from this case you can say that the link is 4, twig is 4 and fundamental loop is equals to number of link. So fundamental loop must be equals to 4. This is the number 2 problem. Number 3, suppose suppose 1, 2, 3 and 4. Okay, so this in this way and this is another way. Okay, so from this case you have to find out number of tree, number 1. Number 2 is number of KCL equation. Number 3, number of KVL equation. How to calculate this? Here is n equals to 4 and B equals to, this is 1, 2, 3, 4, 5, 6, 7, 8. This is 5. Node is 5. 1, 2, 3, 4, 5. So number of node is 5 and branch is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So number of branch is 10. So you have to find out what is this tree. So number of tree is equals to n to the power n minus 2. So it will be 5 to the power 5 minus 2. So 5 to the power 3. So 125. So number of KCL equation, this is so from this equation b equals to n minus 1 plus L. So L equals to b minus n plus 1. So b is 10, 5 plus 1. So this is 6. So number of KVL equation is 6. Okay, and number of KCL equation is n minus 1. So n is 5 minus 1 equals to 4. So this is the problem number 3. So